Everyone is talking about AI coding agents right now. Claude Code, Cursor, Klein, OpenHands. But most people only focus on prompts and models. In reality, enterprise AI coding platforms are much more than chat interface. They are distributed systems with orchestration engines, execution runtimes, sandboxing, memory systems, governance, observability, and security boundaries. In this video, we'll break down how enterprise AI coding agents actually work internally using a concept called harness engineering. Consumer AI coding tools are optimized for individual developers, but enterprises have very different requirements. They need governance, auditability, role based access control, isolated execution, compliance, centralized observability, and approval workflows. Enterprises cannot simply allow an AI agent to run unrestricted commands on developer laptops or production systems. That's why organizations build harness platforms around AI agents. A harness is the runtime operating systems around the AI. It transforms a language model into an autonomous agent. The code engine is usually a while loop. The model thinks, uses tools, observes results, updates context, and continues iterating until the task is completed. Modern harness also manages context windows, memory, permissions, subagents, lifecycle hooks, and safety systems. The model itself is only one component. The harness is the real product. One important architectural concept is the difference between tools and skills. Tools are universal primitives, file operations, terminal executions, Git commands. Skills encode organizational knowledge, things like deployment process, coding standards, infrastructure workflows, and internal engineering practices. Enterprise AI systems become truly valuable when they learn organizational skills, not just generic tools. Let's look at the architecture. The front end is typically built using Next.js. Behind that sits the orchestration layer, often Fast API or Node.js. This layer manages sessions, workflows, memory retrieval, approvals, and policy evaluations. Then comes the worker runtime. This is the system responsible for executing commands, streaming terminal outputs, handling retries, and managing execution jobs. Finally, commands execute inside isolated sandbox environments. A common misconception is that the worker runtime and the sandbox are the same thing. They are related but architecturally different. The worker runtime manages execution logic, process, streaming, orchestration, retries. The sandbox is the isolated environment where execution happens. Docker containers, Kubernetes pods, or micro VMs. This isolation is critical because enterprise AI systems assume the model will fail sometimes. The architecture must contain those failures safely. A practical AWS architecture often looks like this. Users connect through an application load balancer. The front end and orchestrator run on ECS Fargate. PostgreSQL runs on Amazon RDS. Redis queues run on Elastic Cache. Repositories, logs, and artifacts are stored in S3. Worker runtime launch temporary sandbox containers for every execution session. Initially, ECS Fargate is usually simpler than Kubernetes and works extremely well for MPP and early enterprise deployments. Here is the execution flow. The user submits the task, the orchestration decides what tools are needed, which policies to apply, and whether approvals are required. The worker runtime launches an isolated sandbox. The repository is cloned into the environment. Command executes safely inside the container. Logs stream back to the user in real time. Once execution finishes, the sandbox is destroyed. This ephemeral execution model dramatically improves security and isolation. Enterprise AI systems are usually not fully autonomous. They are human supervised autonomous systems. Dangerous actions should always require explicit approvals. Examples include infrastructure changes, destructive file system operations, production deployments, or database migrations. The goal is not replacing developers, the goal is amplifying developers safely. Real enterprise AI systems are difficult operational problems, things like prompt injection, hallucinated commands, runaway token costs, infinite execution loops, multi tenant isolations, and state synchronization. This is why harness engineering is fundamentally a distributed systems problem. You are managing queues, workers, retries, orchestration, observability, and ephemeral compute infrastructure. Not just prompts, observability also becomes critical. Enterprises often care more about auditability, replayability, and execution tracing than raw model quality. The biggest takeaway is this: AI coding agents are not just language models, they are full execution platforms. The real engineering challenge is orchestration, governance, memory, observability, execution safety, and scalable infrastructure. In other words, the harness is the product. If you enjoyed this deep dive into enterprise AI engineering systems, subscribe for more videos on AI infrastructure, agent systems, cloud architecture, and GenAI engineering. Thanks for watching.
Hey everyone! If you're enjoying the content, don't forget to like, share, and subscribe to the channel. Your support means the world to me!